So, um, so we get started. And by the way, feel free to interact if there's any comments or questions. The point is to make this as clear as possible to those here and to those listening during the recording. So first of all, for those who haven't heard, MariaDB is an open source project, a very important open source database that was created as a response to Oracle's acquisition of MySQL, fearing that MySQL will be terming closed source. We actually think that because MariaDB exists, that's why MySQL still is around. MariaDB was named after Monty's youngest daughter, Maria, and I've been told that was, but with getting news approval, that they're allowed to name another database similarly. The first release on MariaDB was very soon after it was created, October 2009. So from April 2009, it's about 6 months to get first release out. And then the year after year, there's been roughly one stable release. The development of MariaDB is guided by the MariaDB Foundation. We have contributors. The biggest contributor is the MariaDB Corporation, but we have many other contributors, other notable ones like Amazon, and some people that are here from SkyScale. They have contributed code to MariaDB or to projects around MariaDB. So we have a strong focus on development alongside and with the community. And the most important part of building an open source community is making it easy for people to contribute, debug code. So the question I get asked quite often is, how do I contribute to an open source project? And you think that coding is the only way to do it. But no, there's many ways to contribute to MariaDB. You can, for instance, the simplest one is help with documentation, help with answering questions. There are many websites, Stack Overflow, Reddit, where people ask questions, and if you know the answer, you can help us by giving that answer back. We have the documentation as a wiki, a knowledge base. You can edit it. So let's have a look at how you can contribute to the knowledge base. You go to mariadb.com/kb. There's a login button, and if you don't have a user, you can create one. So you press on login, you get a page that has this form on the side. Just sign up with any of the authentication methods or create your own account. The only reason why you need an account is for us to be able to know that a user has made changes to the documentation, so we can know who has done what. All contributions, if you can edit a page on the knowledge base, just like you can do a Wikipedia page, we know who edited them, and we review and curate if somebody does, let's say, bad it is. But we can generally don't have a problem with that. Oh, and one final thing, translations are something we really want to get. So if you know a different language than English and you want to translate the documentation, we're very much appreciate that. So this is documentation. And usually the hot topic is, how do I contribute code? Because MariaDB is such an old project with the history of MariaDB and the history of MySQL, it's not the easiest one to get started with. But that doesn't mean it's impossible. So with baby steps, we can get there. So first, let's look at what the flow is to make it the easiest for you to get your contribution in. We have our code on GitHub, which means that we follow the traditional GitHub workflow of you create a pull request to us, you get reviews, you update, you finally merge. The way you start this is you first have to fork MariaDB in GitHub. So you have to fork on GitHub. There's a article, very good article from Wikipedia from GitHub. You should read this one. Then create a patch and submit the pull request. And we'll go step by step on how to do that. So first, since this is a Git repository, you need to have Git installed on your laptop to be able to run source code. On a Debian-based distribution like Debian, Ubuntu, all the other derivatives. You can install Git, and after you install Git, you should also fork the server, follow the tutorial on the previous page. And then Git clone from GitHub, choose your user and your fork of MariaDB to make your lives easier afterwards. You can use the base spreading the server, but if you need to use this one, the rest of the steps are a little bit simpler. So if you clone it, and it's a pretty big repository, so it will take a while. Then you go to the server directory. Inside the server directory, you will find the source code, and now we need to build. Building MariaDB needs a lot of build time dependencies. So you need to install a bunch of libraries, either one by one, or because MariaDB is default in many distributions, there's a package already for it, and you can get the build dependencies for that package directly. So apt-get build dep with MariaDB server, you will get all the libraries you need, build, compile, all the features they bring. You will need to set up the source repositories. So depending on distribution, there's a few different steps here. Actually, I will add a tutorial on how to make sure this is a command to run as well easily. Finally, we have all the dependencies. Now we can start building. Most C and C++ projects have two steps. One is you configure the project, and then you embed. The first step, configure, is done with CMake. The simplest way to build is with CMake dot, without the final part here, but this will build a release binary, which is harder to debug. So we just add one flag, -b CMake build type equals debug. Make sure we compile with optimization is disabled, and with compile with the debug symbols also active. And then we can compile with make -j, pick the number of CPU cores we have. Let's say 8 is a decent number, but if you have more, you can use more. Then build compile server. We also had build scripts. I remember when I first started, I actually started using compile with build scripts. So if you use a build script, you invoke it from the base directory build / and then you pick your configuration. If you have one for debug and everything. So compile Pentium 64 debug pass is the one for build 64. There's one for R, and there are other combinations as well. So behind the scenes, this build script is based on the same thing. It just calls CMake many more flags, and it invokes make the proper number of parallel CPUs. Finally, once to compile, we need to make sure that the code actually in its current state works properly. So we need to be able to test. MariaDB has a test framework called MTR, MariaDB Test Runs, inherited from MySQL Test Run. What this tool does is it runs SQL and checks the output, comparing what the expected output is. So basically, we're just flooding the server with SQL commands and we see if everything works. Of course, there's other kinds of tests in there, but the most of them are like that. So just to start the tests, we go to this MySQL test directory, and then if everything is compiled, you will have this symlink MTR. This is a shorthand to MariaDB test run. So MTR, and then we say we want to test in parallel, let's say 8 threads. If you do manuals, we get a speed up because you can no longer use your disk, you use a RAM disk instead. So parallel should have roughly 2 times the number of CPUs you'd have, and for mem, for it to not crash, you should have about 2 gigs of RAM for each thread you've started. So make the math and figure out what if it's enough. Otherwise, reduce parallel. Or remove mem and see if you can still get faster time. Roughly for a newer CPU, like the latest generation AM new ones, the ones with 16 cores, testing takes about 10 to 15 minutes. So it's still quite a lot of tests, about 7,000 tests. If all tests pass, then you're probably ready to start hacking it. in your own trees. You should write a patch in a separate branch. So the way you do it is you first check out the current development branch, which is called main. So you can check out main, make sure it's up to date, and then make a new branch. Let's call it main patch, and then you move to that other branch. Then you write your patch, permit all the changes. You do git add to get all the changes in, and do a git commit. Make sure the commit message is descriptive, and I have an explanation of what that means in a little bit. Finally, submit the pull request. But this time you push your changes to your fork, and then you go to GitHub, you go to pull requests. There's a button here, new pull request, and you create the pull request here. There's a form there where it says, I want the pull request against the base MariaDB rebel. You pick a branch. It's pretty self-explanatory. And if there are questions, there is the GitHub article I pointed out at the beginning. It has a lot of the edge pieces covered. Finally, once you've created the pull request, we have set up automation where your code gets automatically tested across the whole suite of systems that MariaDB used to run on. You will get this prompt at the beginning of your pull request with checks either ongoing, passed, or fail. These are not all the tests that we run. So to get more tests, you actually need to go to build.mariadb.org. You go to grid, and then you have to add a part of the URL here that corresponds to your pull request. So you just take the string and replace the number here with your pull request number. As I was preparing this presentation, I realized we can make lives easier here by just giving this like a quite once you click pull request. So probably in a week or two, we will have a log that just gives you this link as a comment right after pull requests. So that would be easier to find, so you can see all the paths for your chains. We also have one feature that you cannot get your pull request merged unless a certain set of builders pass. They are called branch protection builders. They're mandatory. If they're red, you cannot push. Not even core developers can force that unless they really do some weird hacks that they really shouldn't. So that's basic GitHub workflow. Now, before you actually start coding something, it's very good to get a feel of what exactly you want to do and if it aligns with the project's goals. So before you attempt any particular task, make sure first that when you read a Jira entry, that you understand what the task is about. Sometimes people have started coding something and it wasn't exactly what the task was about. Finally, you propose a change. If it's a bigger patch, it would be wise first to discuss the architecture or the planned implementation before actually spending, let's say, a few days on it. You might just get a few comments that say that this is not the way it's supposed to be implemented. Have a look at this approach instead. Always ask, either in a comment in a Jira, or go to Zuib and ask us there. We're typically very responsive. Highly recommend you get approval first before working on code direct. And then, to make reviewers' lives easier, make sure that commits are well documented. First, the commit message should explain why and what you're doing. One can be just the mnet number if it's descriptive enough. But sometimes you need to give a bit more context so it's clear. Make sure you add test cases. We get a lot of pull requests that don't have test cases, and sometimes it's hard to understand what the expected change is. With test cases, it's much fewer. Actually, we had a pull request submitted a few days ago, and because it had test cases, I could immediately say, this is wrong, this is how you fix it. The contributor got their review in maybe 1 hour after the pull request. Otherwise, it would have taken me much longer. I would have to spend time to really understand the code. So test cases are very, very much recommended. We also have a code standards file go to Coding Standards MD. Lots of advice and instructions on what to follow to make sure that your code gets accepted without too many nitpicks, coding style-wise. Reviews will come on GitHub as in the form of comments. Here's a pretty long exchange between that Sergey and somebody else. As I said, include test cases. This is an example of something that didn't have that proper test case. That's why you get these long discussions. How you make test cases. I mentioned MySQL test run. So MySQL test run uses a set of test files. They are located in the main folder under MySQL test or in suite folder. They're mostly SQL files, but they have special syntax for special commands that MVR can run. Like you can start a separate process, you can start a separate server, set up replication. Basically what we'll do is it will run those files and we'll compare the output. If it matches, then the test passes. It doesn't match, then the test is failed. And you will get the diff as to why it fails. To create the test case, it's just as simple as creating a file. So let's say here we create a hello test file. This should have been main, not b. That's one mistake. So in main hello test, we can put an SQL command, save it there. If you run it, you will get the output of the SQL command. Finally, if to reach out to us, this is the main discussion channel. We also have presence on IRC, but we try to keep most of our discussions on Zulip. It's going to be pretty user-friendly once we figure out a little bit how to start. We also use mailing lists. MariaDB developers and Discuss are the primary ones. You also have a low traffic announce mailing list. And for a few other ones, just check the URL here. And remember that even though you don't have to contribute code or documentation, a very advanced user explaining clearly how to reproduce a very tricky bug is very valuable. So you can contribute by just finding bugs. If it helps core developers build a reasonable bug fix, that is sometimes worth much more than actually you trying to code something that may or may not work. To find tasks to work on, we have a label called beginner friendly. We have about 97 open tasks right now. I created a filter. Just click on this link, you will get the filter Jira that takes for you to all the open tasks. Basically, the filtering is labeled equals beginner friendly and status equals open. Other projects do the same. So if you want to go to another project and contribute, search for beginner friendly tasks first. Like in TypeScript, they have a label called good first issue. It's the long URL for it, but that's one example. Python has Otis database, and they have a easy issues label. There's a button there you can press. Lots of projects do this. I highly recommend if you want to try out something, search for beginner friendly ones. They're typically tasks that people want to get done, but they are so low priority that they really don't have the time for it. So getting new contributors do this is very valuable. Also, one thing to note is that one area in MariaDB where we try to really shine is we get students year after year as part of Google Summer of Code, and we mentor them. Some end up working for MariaDB. Yours truly. I started as a Google Summer of Code student quite a while ago. Also, we can help with packaging. We work with distribution packagers, but even those people need help. We need help with Debian, you need help with breadcrumb packaging. So any contributions you can do it. If you have packaging expertise, very much appreciated. We also have a bug bounty or a feature bounty. If you can implement an AI framework integration and get your patch upstream into that framework, and you will reward you for that. We have I think it's got €1,500 for it. And finally, We have other projects aside from MariaDB server as part of the MariaDB organization, like the Jupyter kernel. This one's written in Python. We don't have a maintainer for it. If you want to pick it up, he'll be more than happy to work with you on this one. It has very good documentation here, including how to use it and the architecture, how to develop for it. We also have MariaDB Robot, the CI system we've seen. We also work with pull requests, and we have done contributions in the past. Another thing to note, it's important when you contribute something to a code base, the licensing is, a topic people don't want to talk about, but it is important. So in MariaDB, we accept contributions either licensed under BSD license or with the MariaDB contributor agreement. And the main reason for this is that if you give us the code in this form, the MariaDB Foundation can defend your open source rights in port should it come to it. Same is true for the Free Software Foundation. They also require code right attribution. Both of these licensing methods also give you the right to use your code as you see fit. It just gives the foundation a chance to be able to defend in case somebody is infringing on the license agreements. Stand by for more? Okay, we're a bit out of time. I had a few more slides on Git best practices. So I'll just name one thing that really worked for me. So in general, with Git, you have to do X. And the problem is that usually there's multiple ways of doing X, and everybody has their own way of doing it because there's more than one way. There's more than one way to skin a cat. So the way I would recommend anyone who's trying to get an understanding of Git that actually makes sense and can build upon is you start with a simplified mental model, and then you build from there until it matches everything that you mean to do. And the base that I suggest you start off with is everything in Git revolves around the commit. And the commit is a combination of multiple things. It's the commit hash, the author, date, a few other metadata, the commit message, and the dict itself. Dict from here, for instance. So all of these combine together with the parent of the commit, parent or parents, creates the hash. So if you think about that, then all the other commands will start making sense. You just need to figure out what happens with each commit when you do a different Git command. Like for example, the git branch is just a pointer to one commit, and since that commit has parents and parents and parents, you can get the whole history from just one webber. When you create any branch, you just create a pointer to a hash that exists in that tree, nothing else. Okay, and unfortunately we're out of time, so I don't have a time to go through the other commits of other rules, but basically, whenever you write a commit, the thing to keep in mind is try to make it, make sure that all casts pass after that commit, and that it's self-contained, so logically it up, and it makes sense as a whole. You can clean up things with the base and so on. So that's got it. And you're up.